Now, here we want to find the fifth term and the nth term of the geometric sequence with initial term a, which is 6, and the common ratio r, which is 3. So the initial term is 6, means a1 is 6. And then fifth term means we need to find out a5. And nth term means we need to find out an. And here is the n plus 1th term. That's what I wrote here, which is not required to find that. But we need is nth term. Okay? So, how to find it? It is a geometric sequence. Then the common ratio times the previous term will be the second term. So 6 times 3 will be 18. That's the second one. Because the following term, a2, 18, divided by the first term, a1, which is 6, is 18 divided by 6, which is common ratio 3. And then the third one, second one is found already. Third one is 6 times 3 squared. So we know then 3 squared is 9. 6 times 9 is 54. Similarly, for a4, we shall have a 6 times 3 cubed, and we got calculator here. And on the calculator, clean the screen, and we want to use 6 times 3 cubed, 162. Similarly, we can do a5. That's 6 times 3 to the 4th. The answer is 486. 486 divided by 162 is the common ratio of 3. 486 divided by 162 is 3. So what's the pattern here? If here is 2, then the exponent is 1 here. I didn't write, but you can write exponent. If the exponent is 2 here, you can have an index here is 3, sub-index. If exponent is 3, you have a 4 here. Exponent is 4, you have a 5. So if here is n minus 1, here has to be n. That's the nth term. We found it already. Mine here is different. Mine here is n plus 1th term. But here still, this exponent is 1 less than n plus 1. Okay? So, since this is the general term, when n equals 1, you can find out a1. You see, 1 minus 1. When n is 1, that's 3 to the 0, which is 1. 1 times 6, you have a1. Similar pattern, you can have a2. You can have a5, which is the one right here. The reason we wanted to find out a general term is because of what? Is because here you have a fifth term. How about I like you to find out 20th term? You don't want to write 1, 2, 3, 4, 5 until 20. That's a very silly way, huh? So if here you want a 20, you just do 6 times 3 to the what? 19th. If I ask you to find out 50, then here would be 49 on the exponent. Okay, that's important. That's a very big number, by the way. Sometimes the calculator may get overflow. Exponential growth is very rapidly, the number will get bigger. All right, I'll see you next time.